Welcome to Curie Electronics. In this video, we are going to learn about the load cell. So, this is the load cell. Especially, we are mainly focusing on the beam types load cell. Usually, these kind of load cells are used in weighing scales. This load cell consists of, it is usually made up of strain gauges, four strain gauges. And if you see here, there is one arrow they have given here, pointing towards down. Okay, so this is a frame. This is a frame. To that frame, this load cell is attached. This much is the load cell. And here is mentioned 0.3 kg. That is the load cell. It can measure up to 300 grams. And also it will have different specifications that we will see. So this load cell, it has got 4 wires. See, it has got 4 wires, and this between this red and black we will give the excitation voltage. Usually it is 5 volt, or we can use 10 volt also, there is no issue. And the output is this green and white. The green is the plus output, white is the minus output. And there will be one more wire like this. This is the shield. Okay. And you might be wondering, what is this board? Actually, this is the HX711 ADC, analog to digital converter board. It's a 24-bit ADC. Now we are not going to this. In the next video, we will design a weighing machine or weighing scale using this board. So now let's go to the blackboard and see more detail about the load cell. So we are going to learn the working of a load cell. This is the load cell, a beam type load cell we have already seen. So depending upon the weight, that is 5 kg, 5 kg to 10 kg, 20 kg, 100 kg, like that the physical size also varies, these load cells. Now, okay, this load cell, what is a load cell? Load cell is a transducer which measures the applied force on it. Let me write it. A load cell is a transducer which measures the force applied on it. Which measures the force applied on it. This load cell is made up of strain gauges. Strain gauges. So this is the strain gauge. So it is a metallic wire woven in a zigzag form. And we know when the wire dimensions varies, that is when we compress and expand, the physical dimension of the wire varies. So that causes the resistance variation. Actually, we will measure that resistance variation to find the force applied to it. And usually this is made up of this generally it is a combination of copper and nickel. Copper and nickel for the general commercial applications. So a load cell is a transducer which measures the force applied on it, and it consists of strain gauges. And then what is a strain gauge? It is also a sensor which is used to measure strain. What is strain? Change in length by actual length. Okay, next, okay, see the load cell looks like this. See, it has got four strain gauges. 1, 2, 3, 4, and this will be, see here you could see these are the strain gauges. So it is just like a Wheatstone bridge. It is in the form of a Wheatstone bridge. So two are for see there will be these out of these four, two strain gauges are for compressive force, and two are for the tensile force. Here whatever the strain gauge is shown here, it is of 350 ohms. 350 ohm is the when there is no weight placed on the load cell. For this particular configuration, 350 ohm is the strain gauge resistance. It can be 120 also available. Now what happens? See, when you apply weight, when you keep force on it, when you keep here force, then what happens? This resistance varies, 350 ohm. This some will increase, some may decrease. Then what is there? Then we can find what is the voltage difference between this point and this point. How do you find out? Excitation voltage we know. Once we know the change in resistance, we can apply the voltage divider rule and we can find what is the voltage here at this point and what is the voltage at this point. Then we can find out what is the voltage across that ammeter connection. If you take a load cell, the load cell specification is like this. See, when you want to look at a load cell, we don't look at all the specifications. We will see whether it is 5 kg load cell or 2 kg load cell or 1 ton load cell. That's what we are going to see first. Then what do you do? Next, if you want to make a project using this, or if you want to make a project, let's say you want to make a weighing scale using this, then what is the main thing you look for? That is this one. Full scale output equal to 3 millivolt per volt nominal. That means if we excite with 1 volt, if you are the excitation voltage is 1 volt, that is excitation voltage means what? See, instead of 10 volt, 1 volt. If it is 10 volt, for this specification, if you apply 10 volt, then what is going to be the output? Then it is going to be 3 multiplied by 10, that is 30 millivolt. So for this particular specification or particular load cell, if you are giving 10 volt excitation voltage, then when let it be a 5 kg load cell, then when you keep 5 kg load on the load cell, you will get 30 millivolt as the output. Then what is the other factor? Then we will come to know this is the resistance, output resistance and input resistance. So these are the two main factors we will look for to do, and this also you have to see what is the maximum excitation voltage you can apply. So whatever the output, full scale output, or we are getting this output millivolt per volt, using a ADC, we will sample it and display it on the 7-segment display or suitable display device. So here this much information is sufficient here regarding this. Next, what we will do, we will in the next video we will try to build a project with this. We will try to make a simple weighing scale using the using this load cell, that is a beam type load cell. Now how do you make for a simple weighing scale? What do you need? You need a microcontroller. Let it be 8051 or PIC then what do we have? We have the load cell. This load cell output should go to, where should go? We should go to a ADC. Usually we will use HX711. This is the low cost ADC. And from here we will get a 24-bit value that will go to the microprocessor. Then we will process it. Then we can display it on a LCD. LCD, usually not LCD, it is 7 segment. Okay. So I hope you got the basic idea about what is a load cell. It is used to measure the force acting on it, and it can be made in a number of ways. This load cell can many shapes, different shapes. It is there in different shapes, but here we are only considering the beam type load cell. Also, this is consist of bridge, that is and the load cells are usually made up of full bridge configuration. So we can get a Wheatstone bridge. If there is a force applied on it, the strain gauge resistance varies due to strain. Then we can convert that resistance into force applied to it, so that we can measure the weight of the substance or items. If you like the video, please share with your friends and don't forget to hit the like button. Thanks for watching.